So the topic for today is simplifying rational expressions. And rational expressions are expressions with a polynomial in the numerator and a polynomial in the denominator. And I will tell you that there's two main steps to this. You see 3 in this box, but the first one doesn't always apply. The first one is if your expression is written with 0 or negative exponents, you need to write it as a rational expression. That's example D below. We'll be doing one like that. Once that is accomplished, you're going to factor the numerator and denominator. So we're going back to factoring again. And then you're going to cancel the factors that are common to the numerator and denominator. So let's take a look at the very first one here. Remember our factoring steps. In the numerator, you want to first factor out the greatest common factor if you have one. And we do have a greatest common factor, and that happens to be 2x. In parentheses, that leaves us 4x minus 3.
Good morning, middle school teachers. Please put on your TVs for this morning's announcements. Thank you very much.
In the denominator, we do not need to factor because we just have a monomial. So here's what we're going to do. We're now going to cancel common factors. So when we do that, 2 goes into itself once and into 4 twice. We have 1x on the top, 2x's on the bottom. When we cancel 1x out of the top and the bottom, that's going to get rid of x's on the top and leave us just x on the bottom. So here's what we end with. 4x minus 3 over 2x. And you cannot cancel the 4x and the 2x. You cannot cancel parts of binomials. You can only cancel factors that are common. So you could only cancel it here when we had a factor of 2x and a factor of 4x squared. This is not a factor now. This is a term. This 4x is a term. You cannot cancel it with the 2x. All right? Let's go to example B. So if I go to my numerator, I have a greatest common factor of x. Factor that out. Leaves me with x minus 2 in parentheses. My denominator is the difference of 2 squares, x and 2. So this is x plus 2, x minus 2. And now I'm going to cancel common factors. So x minus 2 is common to the numerator and denominator. So I'm going to cancel that. And it leaves me with x over x plus 2. And again, I cannot cancel the x's. On the bottom, the x is not a factor. You cannot cancel part of a binomial. If we look at C, let's go ahead and factor this. When you go to the numerator, you may want to use the box method here. We haven't used the box method in a little bit, but we may want to use that. So if I go over to the side and draw my box, I've got a 5 here and a negative 1 here. I need 2 numbers that multiply to negative 5 and add to positive 4. That's positive 5 and negative 1. My greatest common factor here is 1. 1 times 5 is 5. 1 times negative 1 is negative 1. 5 times 1 is 5. So this means I have x plus 1 and I have 5x minus 1. In my denominator, always look for a greatest common factor first. We have a greatest common factor of 5. In parentheses, that's going to leave us with x squared minus 2x minus 3. And we'll need to go another step to factor that trinomial. So on the top here, I've got x plus 1, 5x minus 1. On the bottom, I have a 5. And I need something that multiplies to negative 3 and adds to negative 2. That's negative 3 and positive 1. So x minus 3, x plus 1. And again, I'm going to cancel things that are common factors to the numerator and denominator. The only thing that's common is the x plus 1. So I'm going to factor that out. And it leaves me with 5x minus 1 on top. On the bottom, 5 times x minus 3. And again, I cannot cancel the 5's because on the top, this 5 is not a factor. It's part of a binomial. You cannot cancel it. If we look at D, this is where we have a negative exponent, and all we want to do with this is write this as a rational expression. So in other words, as a fraction. So when I look at this exponent of negative 2 means, let's move this to the bottom. So on the top, I can go ahead and factor this. All right, so I need two numbers that multiply to negative 6 and add to positive 1. That's positive 3 and negative 2. So x plus 3, x minus 2. And on the bottom, what I will have is x plus 3 quantity squared. I don't need to FOIL this because I'm just going to turn around and factor it again. Here's what's going to happen. On the top, I have 1x plus 3. On the bottom, I have 2 of them. I can cancel out 1. So I'm going to cancel this one and one of these, which is going to mean I have only 1 on the bottom. And so my answer is x minus 2 over x plus 3. And again, I cannot cancel the x's because the x's here are not factors. They are parts of binomials, and you cannot cancel parts of binomials. Now, E is one that I kind of like you to remember. It's a pattern I want you to remember, and that's when you have the same two numbers, both subtracted, and both minus. All right? This does not cancel the 1 because these are not the same. Actually, the top and the bottom are opposites. Here's how we go ahead and simplify this. On one of them, either the top or the bottom, we're going to factor out a negative 1. So let's just say I do this on the bottom, and you can do this on the top, it's fine. If I factor out a negative 1, in parentheses, that leaves me negative 5 plus x in parentheses. Now notice these two things are the same. Both have a positive x and a negative 5. So these can be canceled. And what I'm left with is 1 divided by negative 1, which is just negative 1. All right, let's go to the next page. We've got one that may take a little bit more effort to work on here. First of all, in our numerator, factor out the greatest common factor. It's always your first step. It'll make everything else so much easier. So I'm going to factor out an x squared. In parentheses, that leaves me x squared minus 5x plus 6. On the bottom, I'm going to do the same thing. Factor out my greatest common factor here, which is x. And that leaves me 9 minus x squared. If I go back to that numerator, I want to factor my trinomial, so I need two numbers that multiply to 6 and add to negative 5, and that would be negative 6 and positive 1. So I have x minus 6, x plus 1. In the denominator, I want to factor this. Oops, I have the x squared there, actually. Now notice, this is the difference of two squares. This is not x plus 3x minus 3 because the 9 comes first. If the 9 comes first, then the 3's come first. So this is 3 plus x, 3 minus x. You know what? I actually factored the top wrong here. Let's fix this. Two numbers that multiply to positive 6 and give you a negative have to be two negatives. So this is actually x minus 2, x minus 3. So let's fix that. On the bottom, like we said, we have 3 plus x, 3 minus x. Okay, now we want to cancel. First of all, we have an x squared on top and an x on the bottom. So we can cancel one x out of each. So here this is gone, and this just becomes x. Now, I have an x minus 3 and a 3 minus x. All right, remember, these aren't the same thing. These will cancel, but they don't cancel to 1, they cancel to -1. Because 3 minus x is the same as -1 times -3 plus x. All right? So -3 plus x is the same as x minus 3. This you can cancel. But what was left here is the -1. When you have a negative left over, the best thing to do is put it in front of the entire fraction. All right? Don't put it in the numerator, don't put it in the denominator. Put it in front of the entire fraction. So it looks like this. Negative. On top, we've got x times x minus 2 over 3 plus x. All right, the next thing we're going to do is we're going to talk about the domain and the zeros of a rational expression. And this is important for one particular reason. We've been talking about domain before, and we say the domain of a lot of our functions. So in other words, what x can pretty much be anything. We're all real numbers because we can plug any number in for x in a function. Here's what we have to remember. This is from the beginning of the year. X cannot be any number that makes your denominator equal 0. All right? X cannot be any number that makes your denominator 0. All right? So here's what x can't be. X can't be a 0. If this here x is 0, this whole denominator is 0. X cannot be -3 because -3 plus 3 is 0. 0 times the rest of this stuff is 0. X cannot be +3 because +3 minus 3 is 0, and 0 times the rest of this stuff is 0. So what we say the domain is then is this. All real numbers except x cannot equal 0, x cannot equal -3, x cannot equal +3. We have to be aware of that. X can't be certain things because we cannot have 0 in the denominator. All right? What this is going to mean for us when we graph this is there are going to be breaks in this graph, and we will talk about how this is graphed. Now, we've talked about the zeros of function. The zeros of functions are when our whole function equals 0. Well, this whole function will equal 0 if the numerator is 0. So all we have to do is set the numerator equal to 0. So set the numerator equal to 0 and solve. So here's what I've got. 0 equals x plus 4 times x minus 1. This is already factored for us. So I have, oops, we don't even need to go that route. So either x plus 4 is 0 or x minus 1 is 0. That gives us x equals -4 and x equals 1. These are our zeros. You can remember from the last unit that zeros are actually x-intercepts, all right? And we can look these up on our graph, and we will be doing that. So let's look at the very last example. Given this function, find the domain of the function and the zeros of the function. And you will have to do this tonight in your homework. First thing, factor this. So in our numerator, we're going to want to use the box method to factor this. So I'm just going to go over here on the side of the paper and do the box method. The 2 goes here, the 3 here, 2 times 3 is 6. What multiplies to positive 6 and adds to negative 7? That's negative 1 and negative 6. The GCF here is 2. 2 times 1 is 2. 2 times negative 3 is negative 6. And 1 times negative 1 is negative 1. So here's what I've got. 2x minus 1 and x minus 3. All right, on the bottom, first step, factor out your greatest common factor, which is x. That will leave you x squared plus x minus 2. And we've got to factor that further. So your numerator here stays the same, 2x minus 1, x minus 3. Your denominator, bring the x down. What multiplies to negative 2 and adds to 1? How about plus 2 and minus 1? So x plus 2, x minus 1. Now, find the domain of the function. The domain of the function is all real numbers except whatever will make your denominator 0. So if x is 0, this whole denominator is going to be 0. So x cannot be 0. X can't be negative 2, because then you would have negative 2 plus 2. That would give you a 0 times the rest of this stuff is 0. So x cannot be negative 2. And finally, x cannot be 1, because 1 minus 1 is 0. 0 times the rest of this stuff gives you 0. So x cannot be 1. And there is your domain. Those are the things that x cannot be. Next, find the zeros of the function. Remember how we said to do this. All you have to do is set your numerator equal to 0. It's already factored. So 0 equals 2x minus 1 times x minus 3, which means 2x minus 1 is 0, and x minus 3 is 0. This one will give you x equals 1/2. This will give you x equals 3. And these are your zeros.